Hi everyone, welcome to the Car Chat podcast. I'm Sam Moores, and with us today we have Thomas Yates. Hello.
Hi Sam. My name is Thomas Yates and I'm the Managing Director of McMurtry Automotive. McMurtry Automotive is a company that I founded with some amazing colleagues in 2016. We actually kicked off the company in September 2016, and we have quietly in secret been producing the most amazing electric car. We launched it at Goodwood last year for the first time, showed the world what we produced. Yes.
Yeah, it's a crazy little thing. We'll come to that. But how did you get into all of this? You know, have you worked in the car industry for a while? Talk me through your sort of journey. How did you start out in this space and stuff like that?
Sure. So I guess the journey for me was one in the direction mostly of engineering, and that began. Probably the most significant event for me right at the beginning was when I was about 4 years old with my father, a broken down lawnmower, single cylinder engine, and an opportune moment to start taking things apart. And so sat in the garage with my old man. We stripped it down, found that it got a failed little end. The gudgeon pin broke away from the piston, and that's why it broke. And for me, just seeing all of those moving parts, oily pistons, conrods, crankshafts, etc., just suddenly put me up on this path of just having an absolute love for combustion engines, which might be quite funny to hear because obviously we're an electric car company. But yeah, and then sort of progressing from that, I guess I had an absolute love for anything that was small and fast and had an engine in it. So particularly go-karts, ATVs, jet skis, those sorts of vehicles that were focused on the individual and the opportunity to go really, really fast. They were super exciting to me. And when I was about 8 years old, I finally got my first quad bike, and I sort of would go absolutely romping around farm and whatnot, and enjoying myself on that. And then sort of finally, by the age of 14, in fact, I think, I got my first opportunity to go racing. So the sort of natural trajectory for me was starting off with a bit of ATV endurance racing and then moving into motocross swiftly after that. And it was just phenomenal, the sort of the speed, the sensation. I think motocross is a very interesting and an exciting motorsport because it's very three-dimensional. I absolutely love circuit racing these days because it's a very, very sort of pure form of precision driving, and a lot of it's about being able to be incredibly repeat the same movements and achieve the same corner apexes, braking points, etc. with circuit racing. But motocross was very different to that. It was much more about dealing with an evolving circuit and continually evolving conditions and dealing with vertical distances as well as longitudinal distances. So yeah, that was a really cool time. I raced until I was about 17, and then I had a big shunt, broke my back, and that sort of began a fun few years of attempting rallying because that's sort of the obvious, safer next step. So for me, it was then into a very basic Peugeot 205 rally car. And a bit of a rocky road towards starting rallying. So the first ever rally I did, I wrapped it square around a tree, which was really short-lived, unfortunately. But then we rebuilt it into a donor Peugeot 205 and had another go. And from there on in was much, much better. And then there's this really sort of the fun aspect of amateur rallying is that you have to convince friends and family that you're a good enough driver that they want to co-drive for you and they want to sit with you while you're doing lots of silly things. And so for me, it was sort of a combination of doing some road rallying, so things called 12 cars, which I can't believe to this day are still sort of legal on British roads because they are phenomenally. They're wonderful for the driver, but it's amazing that there's sort of real motorsport on open public roads, which is really, really cool. But quite terrifying at times too.
What is that?
So 12 car, as the name suggests, is a 12 car road rally. I don't know if they still happen, but certainly 10 years ago or so they did. They're run by local motor clubs usually, and you sort of do various road stages where you have to adhere to certain times. You have to effectively start and finish on what is a very, very tight and twisty country lane at particular times, and the average speed from memory that you need to meet is sort of 30 or 40 miles an hour, something not particularly that high, but the roads are so tight that actually that becomes a really quite a feat. And so, yeah, they're phenomenal things. They're quite archaic, I think, but a beautiful sort of motorsport that seems to have been left untouched and still certainly then still existed on British roads. So fair bit of that road rallying with friends, and we had some. In fact, one of my colleagues at the company here managed to wrap a Peugeot 206 around a fence post as a result of one of those rallies, and we've had a few interesting. I think there's another example of actually another Peugeot 206 going upside down over a stone brick wall at one of the events, which is very surprising for, again, on public roads. But it's this wonderful sort of motorsport, and I did that alongside a bit of endurance rallying and stage rallying too, which I sort of progressed to, and it was all great fun. And I think by the end of it, I wouldn't say it was fantastic, but I had sort of a few stage outright wins. They progressed from a Peugeot 205 to eventually an MGZR rally car that we sort of prepped. And from then, I think that was sort of while I started university. So I went on to university, did a mechanical engineering degree, which at Bath, which led to McMurtry in the end, which I can talk about in a moment. And there was this wonderful opportunity at Bath to do former student, which is so that was quite a long time ago as well. But it's sort of in the early years while former student was setting up. But it was this wonderful situation where you effectively build a race team with a bunch of mates, build a race car and go racing. And so we raced in California, we raced in Germany and Silverstone with this phenomenal Aprilia engined single-seater race car that we built from scratch. So that was wonderful in terms of the experience of building a whole car and meeting lots of really talented people and getting super excited about going fast. And in the meantime, I was starting to do some go-kart racing with the university, which was great, actually starting to get better at circuit racing myself. Even did the odd jet ski race, which was ridiculous because I had sort of like a 20-year-old stand-up Yamaha Superjet, but it's super cool. So just really enjoying all aspects of motorsport. And then while I was at university, I got some interesting. I just got a few lucky breaks really. I went off and worked for what's effectively a vehicle and engine test company. People that would sort of install dynos, engine developers. And one of the jobs that they had on was installing a combustion air handling unit for Mercedes Formula One team. And I got wind of this, and I sort of absolutely put my store out that I had to go and help with the installation of this device. And sort of begrudgingly they let me do this. And so I went to Mercedes at Brixworth, and this is back in 2007. And I alongside installing this unit, I just put about 6 CVs on the relevant. Basically handed them into reception, knowing the sort of key engineering heads, and lo and behold, it worked. So in the meantime, I spent a bit of time while in my sort of university break at Shoreham, working for Ricardo down near Brighton, working on engines, which was great. But then subsequently, finally got the call back from Mercedes, and so spent some time working at Mercedes Formula One while I was still at uni. And that
nice.
It was just so cool. I mean, I was so lucky because I got to go to the company while we were still working on V8s. They had these absolutely screaming V8 Formula One engines on the dyno. And you're just sat there basically like knowing that if you type the wrong thing, you can completely screw it. But yeah, it was a phenomenally exciting time. And I got a whiff, even though I was just there on a few placements to start with, was lucky in that I managed to get a part that I was working on onto Lewis's engine in 2008, and I got a whiff of this potential performance improvement. It probably was nothing, but at the time I had a very simple test that I ran it without and I ran it with, and it made something like half a horsepower. And this was just like the most amazing thing in the world to me, that here was a Formula One engine in Lewis's car that I'd managed to just gain this tiny little bit of performance, but it just felt fantastic. And
that's worth like 500 grand or something.
Yeah,
that performance game.
And it was probably just like the error in the test. It probably wasn't even a real game. But I remember just driving home and just calling my best mate at the time, being like, "This is the coolest day ever." So that was a fun time. Went through university, did the Formula Student, which was just amazing, competing out in different countries, and then left university, and I got a real keenness to spend a little bit of time in Germany. I studied German language at school and at university, and I just thought, crikey, it'd be really lovely to use this. So I managed to get an opportunity to work for Mercedes-AMG road cars over in Falterbach in near Stuttgart, and it was such an awesome culture. And suddenly it's this lovely sound whenever you get in the morning. You hear all the AMGs arriving, and they're just like blah, blah, blah. And like all the employees in their AMGs, and you just think like this is just
nice.
Absolute heaven. So that was quite a short-lived but really wonderful time. And the car I actually ended up working on predominantly was the really hot A45 A class, which was a four-cylinder,
but first generation.
Correct. Yeah.
And what were you doing? What sort of thing, when you were working on it? What did that look like?
So for me, that particular placement was all about project management and trying to help the engineers make sure that they were delivering what they needed to deliver to get the project done. So it was, even though I'd sort of got a technical background as a UK person with pidgin German, I think they probably did the right thing to stick me in a sort of a project management type role to start with, and it worked really well, and it gave me the opportunity to really improve the language, which was fantastic. And then, sorry, stop me if I borrow you, but
no.
About half a year after going to Germany, I got a phone call from Mercedes HPP in Brixworth again, which was a bit out of the blue, but was like, it's always nice to have a phone call from them. And they basically said, "We'd love you to come back, please." And that was that. That was the end of my enjoyable time in Germany. So I rejoined Mercedes Formula One engines. I did this really hard project for a couple of years that was really focused on business change, and it was phenomenally challenging, but pretty rewarding in the end. And I feel like I worked phenomenally hard on this project, and I met all the right people. And then this opportunity came up to be back in the seat that I've got this glimmer of enjoyment from when I was on placement. So an opportunity in what they call the performance development team. And
right.
And then I managed to get sort of 18 months working. And I think arguably it's probably one of the coolest jobs in Formula One, full stop, where your entire remit is make this engine more powerful. And,
nice.
And it's just amazing. The kind of hardware you get to work with is outstanding. So I got to run some wonderful tests. I remember one of my sort of most memorable situations was sitting there at the beginning of the 2014 testing when we just moved over to hybrid, and just none of us had any idea where Ferrari were and where Renault were, and we were all just sat there glued to the screens, and you suddenly get this eureka moment where you realise that all the Mercedes cars are absolutely flying and that everyone else is struggling. And I got this wonderful opportunity to work on all sorts of crazy out there solutions to try and just generate more power in the engines and in the hybrid systems too. And then almost as though it was karma, really. I had then a discussion with the managing director Andy Cowell at the time, and he wanted me to move from that team and then run the durability team. And so it was almost like all of this
not quite so interesting.
Amazing. Yeah, well, all of
I was
this
like, it's not
amazing.
quite so.
Well,
Karen.
it's really fulfilling. But it's basically like you've made this. You've worked really hard to make this engine more powerful, and now it's less reliable. And now you need to
Yeah,
work for the team that deals with the fact that it's less reliable. It was grueling but amazing. I mean, it was 24 hours a day with a team running engines till they basically exploded, and
yeah,
looking at the reasons why they exploded, and trying to understand whether we had a power unit that would survive all the Grand Prix that it needed to do. Um, and we had some really successful times. I was lucky in that the sort of the period that we were running what they call long runs, which is sort of a full engine life on the dyno, so replicating everything that they could of the race environment. So the engines would be there just blatting through laps, and yeah, we got through that time, and luckily we managed to get through all the engines in advance of the season that started. So it was phenomenal. But then, sort of out of the blue, completely out of the blue, came a phone call from Sir David McMurtry, who I didn't know an awful lot about at that point, who'd been in touch with Bath University, spoke to a chap called Geraint Owen, who's a phenomenal lecturer at Bath University, and said, I would like a new car company. Can you point me towards a sensible person? And out of the blue came a phone call. And then a few weeks later, you find yourself sitting in an office with a phenomenally successful engineering entrepreneur, talking about setting up a car company. And I'll gladly tell you a lot more about Sir David as well if you're interested.
yeah. But okay, I want to wind back a little bit.
Sure.
Just absolutely, we'll get to this in like 1 second. But I want to know that bit, right, where you've got a whole bunch of new regs or whatever. You're building an engine, and you've got whatever the first test where you're going to see what everyone else is doing. Does anyone have any idea roughly like where everyone should be? Because you're all starting from like a point, I guess, and you're like, we're just iterating and trying to make this as powerful, as reliable. Presuming there's a nice, we see some cars blowing up this year, but like you're pushing that as much. But like, do you have any idea where anyone else is?
I have to say, at that point, with a rule change that was as significant as that, the change from the V8 to the V6, certainly anyone that I had access to at that company was clueless. We were all just crossing our fingers because it's such a radical change, and I suspect it was really similar for the most recent changes this year. That there's such a significant change. You've got no real previous data that will give you an indication. I mean, clearly you know that the top teams are going to be pumping the most resources at it, and therefore, in probability, should do really well. But there were such different design philosophies as well, because I don't know if you recall, but back then the massive talking point about Mercedes was the turbocharger that effectively had the compressor at one end of the engine and the turbine at the other end of the engine, and this really long shaft that span really quickly. And that was a complete nightmare to develop. It so nearly just completely derailed the development of that engine. There were times when that was the single most difficult part of the development process. But then obviously we arrived in 2014, and certainly Renault had a completely different concept where you've got a compressor and a turbocharger at one end of the engine, which gave them a much more difficult package. And it's things like that. You do, when you get a lot of cross poaching of people, I think it becomes you get rumours and you get a bit of an idea. But certainly in that situation, in that year, we were all completely clueless and wonderfully sort of surprised and impressed at how well the cars were performing.
And like that initial stage, presumably of like coming up with a basic design that you're then gonna work. As you say, like each company or group does it slightly differently and comes up with a slightly different solution. And then how on earth do you know or have an idea of like, presuming you come up with do you come up with like a few options, iterate, like work on them a bit and see which is progressing the fastest, or you just go, nah, this one simulates the best?
I think you do have multiple options. Certainly, the conceptual stage. I mean, if you look way back when they first introduced KERS, so it's
Mm.
2009, where Jensen won with Braun, wasn't it? It was the first sort of proper introduction of KERS, and I remember back then there were on the table there were mechanical solutions to doing sort of flywheel energy storage versus electrical solutions that used a battery and an electric motor.
Yeah.
And initially, lots of teams, I think, were trying to develop both options and trying to really progress both options as far as they could to see which was best. But eventually, you absolutely have to pick one and back your horse and just go for it, because you pay a huge penalty by splitting your team and by trying to cover too much, I think. So the sooner you can decide, the better.
Mm. Yeah. That makes sense. So that is like test day one, the most tense. Obviously, there's difference, but like part of the whole development progress where you're like, okay, now I know where we are, or not.
Yes, I think that absolutely is true, because very very quickly after the first test, you get to see what everyone has produced. Um, uh, and to be honest, it's been similar at McMurtry as well. The first day that we tested our new Speirling, right, sort of 3 days before Goodwood last year, was one of it was terrifying, to be honest. And actually, what's even funnier is that it was actually me in the driving seat as soon as we turned the power up. So it was, I didn't just have the fear of is this car going to work and do everything we want, but even more so, it was the concern of is my driving talent up to the job to not let down our entire team. So yeah, the first test is by far the most scary, I think.
Yeah. Okay. So you get to this point where you meet Sir David McMurtry, comes out of the woodwork.
Correct.
I mean, he's been around for a while, and like talk me through that first bit and like, I want to start a company. Where are we going to go with this?
Yeah, so I mean, so David is he's just an astounding character. He's an inventor through and through, and just a phenomenal genius. And it's easy to say that, but having worked with him for sort of 5.5 years now, he's 100% the truth. His background was working on aero engines. So he's one of the chief engineers on the Olympus Concorde engine. And this was back in the days when they were drawing things on drawing boards and manufacturing something that could fly at Mach I don't know what, but still they were hand drawing the drawings.
Yeah.
And then he progressed, seeing one of the key engineering challenges with the jet engines was actually being able to measure what they produced. The turbine blades needed to be manufactured to such a fine tolerance to get the highest efficiency and the best reliability. So he came up with this idea of a touch trigger probe, which is effectively a little device with a ball on the end that allows you to touch things and measure exactly what you've manufactured.
Okay. Yeah.
And that then grew into this whole Renishaw empire. I guess it's this phenomenal company, and it's worth saying that through his invention there, he has most likely positively influenced all of our sort of experiences of mechanical things that we buy and use. Everything from planes to cars to all the sort of domestic products that we have. If you think about if one of the sort of key challenges with really classic cars is the manufacturing tolerance of things like cylinder bores, pistons, and so forth, which could lead to relatively large inconsistencies in sort of performance and the reliability of the engines that you get. And the whole concept of this touch trigger probe is that it tells you exactly what you've made. So if you've achieved a certain cylinder bore, you can manufacture exactly the right piston to fit in that cylinder bore and deliver exactly what you want from an engine. And that's just one example, but it sort of applies to everything from turbine blades to dampers, etc. So he then sort of went into 3D printing and all sorts of other clever. He's been at it for a very, very long time. He's a phenomenal inventor. And then he came to me, and he is basically his intention was to really, he spent all of these years looking at automotive, seeing how sort of conservative the approaches are within automotive, the limited innovation that we see at a top level, and he got some key ideas. Fundamentally, one of the things that we really shared as a concept is that cars have just got too big. And me, as a lover of small things with engines, that's the first thing that got me excited. So the original sort of the first concept that we've really tried to work on is how do we deliver, what are the important things for a road car? And we strongly believe that the two most important attributes of a good road car, regardless of whether it's got an engine or an electric powertrain, is that it should be compact, so that you really get to enjoy the road, you really get to maximize your opportunities to apex and to not worry about curves, etc. But also it needs to be really, really lightweight. Weight is just the most important factor when in terms of enjoyment of a car, in my opinion, and shared by Sir David. So we sort of conceived this idea of delivering this amazing small electric car, and it was at that point that I guess we had this opportunity to effectively create the dream team. All of those wonderful people that you have great experiences with in life. Is sort of the opportunity to try and to bring them all in to create this amazing new product. And Kevin Ukoko Rangene, who's our chief engineer, I really have to say he was sort of the key driving force that gave me the confidence to just say, okay, this cool thing that I'm doing at Mercedes, I'm gonna leave that because this is going to be amazing. Let's get on and do this McMurtry. And I don't think necessarily without him I would have the confidence to do that. But then, so with Kevin and we were able to sort of form this group. So September 2016, we're sitting on the concrete floor in a building that Sir David's provided, with a small group of us, and we got started. Worked really hard on delivering a first generation car, and that taught us a huge amount about the intricacies and the challenges associated with delivering a good battery electric car. It was always going to be electric from our perspective. It's just the right choice. And then we sort of progressed after a couple of years onto the second generation car, and we had this opportunity to have a real rethink about how can we make this thing great? How can we apply even greater levels of innovation and really start to try and reinvent things? So we came up with this concept of something that's clearly it's small. It's of historic proportion. So it's actually, the McMurtry Speirling is actually a very similar size to the Lotus 18 1960s Formula One car that Sterling Moss won at Monaco in. So it's a classic racing car size. Rather, it's probably half the footprint of a modern F1. We looked at the banned 1970s technologies. So fan systems, which in principle was a really interesting technology, but realistically politics got in the way of. When you look at the reasons why it got banned back in the 70s, a lot of it was political more so than actually technical. So we looked at bringing in these sort of historic technologies that got ignored in the past, like fan powered downforce and active suspension, and we applied those to the vehicle, and then brought in what we'd learned from the first generation car, fully electric powertrain. How do we get the absolute most out of an electric powertrain and make this car relevant for the future too? And therein the sort of the McMurtry Speirling was born, and it was this. We had to be phenomenally brave and absolute hats off to Sir David McMurtry for backing us to do this, but to design a complete car around the concept of pulling a vacuum that you manage, a sealed vacuum, effectively build yourself a 200-mile-an-hour vacuum cleaner, and design a complete car at the cost, the expense, and the effort around this concept that we, at that point, the closest we got to proving it was we built we put a vacuum system into an old ambulance, and the reason being because vans are fantastic because you've got loads of room in the back to build development parts on. And the fastest van that you can buy is an ambulance. And so we built an ambulance with a vacuum system in it, and we were lapping Thruxton with it. And the Thruxton guys thought we were developing a new sort of jet engine, because that was a lovely byproduct of the whole thing as well, is that you've got this wonderful noise from the system. It's really loud, but a sort of a high frequency noise. So we never set up any of the noise alarms. It's just when you get close to it, it's really sort of really loud. We designed after doing multiple laps of Thruxton in an ambulance that had a vacuum system on it. We said, right, that's it. We're now developing a 200 mile an hour, more than 200 mile an hour electric car around this concept. Let's go for it. And that was a few years ago. And it's actually only more recently, it's only in the last few months where we finally got to the point where we've gone, my goodness, this really, really works. And this is just so fantastic. And it's been phenomenal, the sort of progress that we've made. We were ultra lucky to tie up with so I went to the King's School Worcester up in West Midlands, and Derek Bell, quite a few years before me, also went to the King's School Worcester, and he went to do a presentation to young people to inspire them about the sort of having this wonderful career in racing and motorsport, and that was great. And I found out about this through a friend, and went, oh my God, we went to the same school. So contacted them through the Old Boys Network, and they put me in touch with Derek. And he sort of said, well, if it's not got a V8 or a V12, I'm not sure I'm interested. But then sort of as the story goes, and 12 months later, he was driving our car up Goodwood, having a really good time with it. And so it was wonderful to tie up with him. And then through the event that we've done at Goodwood, we managed to tie up with Max Chilton too. And now Max, who's just a phenomenal driver. I think seeing Max in our car, and we're mainly made up of a team of people that like to drive. And so a large proportion of us have had a go in our car. But then you suddenly see what it is for us to have a go versus watching the onboard footage of Max Chilton driving. And you realise how incompetent and inadequate you are, which is wonderful to see. We in the last few months, we've had Max running in the car. We've had the vacuum system working fantastically well. And it's been really great to get this feedback of really interesting things that we've never thought about before. For example, with the vacuum system downforce, aside from inherently being a very, very efficient way of delivering downforce, could save loads of fuel in Formula One if they wanted to, as an example. You get this perfectly flat sort of downforce level. And for Max, that was really interesting, because the feedback from him was straight away, I don't have to bleed off the brake pedal. This is amazing. Because in all the sort of pieces that he's driven, obviously, as you slow down, the aero load comes off, and then you need to be out of the brake pedal or you lock up. But we've just got this flat pan downforce that we've now proven up to. We've done 190 miles an hour around Silverstone and looked at the trace, and it's just perfect. And it's just made us very, very happy, because, to be honest, it was stressful and we were a bit worried that it wasn't going to work. But
that must be. I can't remotely imagine what that's like, because I've only driven something with conventional, decent amount, but conventional downforce. And then, okay, so does it have like I know previously cars used to have like a kind of like a skirt that goes down to the ground. Does it have a skirt?
Correct. Yeah. So that's the key to it all working really well, because so if you think about an aerodynamic wing, effectively the drag and the downforce that you get go up with the square of speed. So at the point that you're doing sort of 200 miles an hour plus, you're actually using a huge amount of power just dragging this wing through the air, and it's giving you loads and loads of downforce to the point that your tires are getting really squished and overheating, and actually often that's down the straight when you don't need the downforce at all anyway.
Yeah.
With a vacuum system, if you've got it really well sealed, so the power that you need to run the fans is directly proportional to the flow rate of air effectively being drawn, that's leaking through the seals, and the pressure at which you're pulling it. So if you do a really good job of sealing your skirts effectively, the power that you need to run to the system tends towards zero. So the better you get at it, the less power you actually need to deliver exactly the same downforce. And for an electric car, where energy consumption is absolutely critical to everything, because it just means battery weight. It's a system we've been developing for 3 years now, probably 3.5 in fact. And where we sort of picked up was about what we could learn about it from the 1970s, and we've had to push sort of completely through. There's quite a lot of different features on the system that we haven't really described. One of them is well inspired by Sir David McMurtry. So it's at this present point, it's a dual redundant system. So you've, just like an aircraft, you've got twin fan system. If you ever had one that failed or went wrong for some reason, the other fan is enough to give you the majority of the downforce still. Yes,
that was going to be one of my questions.
Yeah.
Because if it's one fan and it fails, you're in a big problem.
Yes.
If the downforce just goes to zero, you're going off.
Yes, and it also, but it gives you some really interesting. I get so excited about the concept of doing this on a race car, because the other thing that everyone's always complaining about in Formula One is people overusing curbs, it's track limits, it's the fact that there's tarmac now on the far side of every curb, so they don't really get penalised.
Yeah.
With this kind of system, so the whole concept is obviously it seals against the ground. I mean, initially we were sort of worried: is it going to damage the tarmac? Is this going to be a problem? And wonderfully, through an awful lot of hard graft and development, it's not an issue at all. We've got a system that's working really, really well, and no issues whatsoever on that side. But one of the things is as you get over a curb, obviously a sawtooth curb has got these massive sort of cavities in it, which suddenly allow flow to come through. So you get this really cool situation where if a driver with a system like this was to properly go over track limits, they get negatively penalised because they've got nothing like as much downforce as they would do normally. So it's I think that the potential for keeping people within track limits is much greater, and you get this sort of exciting difference.
Yeah, presumably that's the same if you went over grass or a different surface or something that's probably not a bit of runoff, not a problem.
Yeah.
But yeah, like a curb or something like that. Obviously, gravel's going to slow everyone down. But yeah, that's quite interesting. Does it drop off? Like if you go over a curb, does it suddenly drop by quite a lot, or just like how does it like bleed off, or how does that? Does it suddenly just go ping?
It's a bit of a bleed, and actually one of the things that we've realised as a result of now actually having built a car and been lapping Silverstone is that the best implementation of this kind of system is in a little bit of combination with traditional aerodynamics. So you've got your trusty old wings that, as long as they don't fall off, they'll give you a reasonable bit of downforce for too much drag. But if you don't try and do massive sort of numbers, you can get a low level of downforce from an aero package, and then combine that with an underfloor downforce system like we've produced, and then effectively that gives you a base level of downforce that, regardless of what you're getting from your underfloor, makes the car stable. It's inherently safe, but then you get the real performance then comes from the vacuum system under the car. One of the things that's really interesting is the ability to deliver lap time around slow corners. So obviously all conventional cars currently, if you go into a really tight corner, you get this compound effect. You've inherently got a tight corner which requires you to go slowly, but as you're slowing down, all the aero loadings come off, so you end up going around really slowly. Whereas with this kind of concept, you've got full downforce regardless of the speed. So for things, not that we've really tried to get involved in it, but in the road car industry, there's this sort of 0 to 60 battle that's going on, where everyone seems to have plateaued around sort of 1.8 seconds, and all the cars are effectively the traction limit for the best Pirellis or Michelins that you can put on it. That's about where you can get to.
Presumably you can monster this.
Absolutely, you can have you name your number and you just add the torque. Here's the downforce. So yeah, that's one of the reasons we get a lot of questions with the car as to why is it just rear wheel drive? All these EVs are now 4-wheel drive, and when you've got limitless downforce, the compromises are just different. So we can still do a tremendous amount of regenerative braking on the rear axle, more than we need to sort of fully push the battery to its limits. So yeah, it's a different set of compromises. When you're trying to go as fast as we are with this electric car at the moment, I think the sort of power numbers that we're measuring from the brakes are sort of measured in megawatts now, which means that you just can't get that back into a battery.
Yeah. Wow, that this opens up so many options for a driving experience that's just so different to something else. Like that is, I think. Can you with the fan running? Do you run it at like max? Not necessarily max, but like you're picking 500 kilos of downforce or whatever. Do you run it at 500 kilos of downforce all the time, or presumably, if you wanted to, can you like turn? Is that the most it can get, or if you run it harder, use more power, can you get 600?
So I guess the first thing to say is that when we announced those 500 kilo numbers, that was Goodwood last year, and we didn't have the system working that well, and I felt it was important to write some really conservative numbers down. So the actual numbers are a huge amount more than 500 kilos.
Okay.
But there's also you can effectively do whatever you want with the downforce profile. So you could match the downforce of a normal aero car just by ramping up fan speed with car speed, if you wanted that sort of experience. We're sort of working on a DRS function at the moment, so you inherently get this big benefit of the better job you can do of sealing the system, the more the power that you use to deliver the downforce tends towards zero. But also you've got this opportunity to very easily control your entire downforce just by the speed of a fan. So you can have a DRS paddle in the same way as you would on in an F1 car. But you can bring the whole downforce package down to a lower level of power consumption rather than just a rear wing, or you effectively have control of the whole thing. And the other thing I guess that people maybe don't realise yet, but the seal system is really small. So the footprint of our of the downforce generating element of our car is actually really small. It's not like a chaparral where you've got these great big skirts down the side of the car and they're trying to pull vacuum across the whole thing. It's a really compact system, which helps keep the whole car light and
And do you have? Is there any element of, I guess, like a bit like a ramjet, but not quite like a ramjet, where if you go faster, do you use any external air to spin the fan?
So one effect that you do get is that you get a low pressure region. So the fan exits are at the back of the car, and as a result of driving fast, you get a low pressure region behind those fan exits. So you do benefit the fans, but you're not spinning the fan so much as you're generating a beneficial pressure ratio for the fans are working to. So the air that they're trying to push against is less than atmosphere, which is helpful. So you do.
So it uses less power, etc.
You get a bit of a ram air effect, yes.
Interesting. And then, okay, so this scenario where you're running like all of the downforce around a hairpin, what sort of speed differentials have you seen versus like I'm not going to say road cars, but like a race car on slicks, or even you running without and then on around a hairpin?
So the best comparison that we've been able to make so far are the slow corners around Silverstone. We kind of got given some onboard footage from a top spec Huracan GT3.
I've seen this.
Trying to follow us through the low speed corners, and it actually the speed delta is so large that it caused the driver of the Huracan to completely miss their braking point, and then. And then almost sort of lose it because it's just like someone came to us after the event and said your car just looks like a video game. I didn't know what to say to that, but I completely understand what he meant. It looks completely surreal through this slow speed corner. So I guess the only way to really quantify it is. I mean, we're not yet quoting exactly the G we're pulling because we're continually improving the system and we're making it lighter every week. The car's getting faster, but we're definitely in. We've got a car now that's pulling multiple G, and it does that in low speed hairpins and it does that in high speed corners in the same way.
Above 2 at 0 miles an hour. or 1 mile an hour.
Above 2.
No, obviously it can't be like that. So,
Yeah.
but
yeah, above 2 round
everywhere.
any hair, high speed, low speed corners is absolutely doable. Yeah.
Wow.
It's cool.
Because that is actually really cool. Like, irrespective of whether you want like an electric powertrain or not. I've driven. I have a Radical SR3, and so go around sections of Silverstone, like Max Beckett's and stuff like that. It's like 2.5G, something like that, which feels pretty awesome. But you wait then pretty much for like, not quite, but you know, a lot of the lap to get back to some of those sections where you're pulling the G force. And the idea of pulling that much G round a slow speed corner sounds just, that blows my mind. Because you're in the corner, like you're going, keep going round and round and round, and just keep going.
Well, one of the things that the thing that's on test today over at the airfield that Max is testing as we speak is we've had to implement power steering because you've got to be the low speed corners. You've got to be able to move the steering wheel so quickly to be able to do the car's potential. But actually, we're sort of the opinion now that we think Max is relatively superhuman because we've seen him. We've got a tiny steering wheel like this, and we've seen him on the day to do 60 Newton meters, which is just these F1 drivers are blooming strong. But even so, he's given us the feedback that he just can't. It's the weight of the steering that's holding him back rather than rather than the car's potential. So the key thing that we're pushing on at the moment is getting a really good power steering unit working, just so that we can really get the most out of these low speed corners. Because I really like the idea of the fun thought is what would it really be like to go around the hairpin at Monaco, because it would be so much faster than a Formula 1 car. The whole
so
track
much faster.
It's a cool concept, and we work really, really hard to deliver it. It's not been easy at all, and that's why actually when we went up Goodwood last year, we didn't have anything like the figures we were hoping for. But as I say, in these last few months, we've had a breakthrough, and I sort of don't really mind sharing that Silverstone now we've got to the point that we're sort of comparable to about an LMP2 car in terms of outright pace.
That's pretty great.
Yes, for a car that's as small as ours, we're really, really pleased, and there's a lot more to go yet. That's running things like fans at 75% and not giving it all the power, and Max not having had power steering before. And there's so much that we're working on and building on. The car is going to be brutally fast, and then I guess the exciting thing is one of the things I'm most excited about now is when we start trying to stick number plates on it.
So talk to me about this. Well, actually, I've got a couple of more bits, and then we can cover it as and when or whatever. But battery packs and stuff like that. What's the size of battery pack in it, and where did that come from?
So the battery pack in the car that the one prototype that we're running at the moment is 60 kilowatt hours. It's about if it was a Tesla Model 3 equivalent, it's about middle of the range. It's above the bottom and below the top. It's completely designed and delivered by us. McMurtry Automotive is a company. The battery pack itself is a wraparound U shape, so it's it's formed around the driver. It's sort of either side and then under the driver's legs, and it's not something you can just go and buy. And the powers that we're trying to pull with the traction system and with the fan system on top of that as well are absolutely astronomical. So it's all done by us, and it's I don't know for a fact, but it's I think it would be relatively easy to argue that it's one of the most power dense battery packs in existence, and we've just been forced to push the absolute nth degree to get that within a tiny car that weighs south of a ton to deliver a 60 kilowatt hour battery pack and all this horsepower and a fan system and everything else. It's some really difficult work, but we've done it.
And then I was just looking at your sort of specs on the website, and it says charge rate up to 600 kilowatts peak. That sounds like a shit ton of power.
Yeah, so it's worth saying with that, this whole sort of there's some really interesting routes with this car. If and when we start doing some racing with it, the concept of a pit stop charge is something that's quite an interesting prospect. And so for a short, sharp burst, that's the sort of power that you can pump in. But you're right, that is a very large number. And you would expect a significant amount of battery heating to achieve that. But for a short, sharp, I'm in a pit stop, I'm going to give it a few seconds of as much as I could possibly pump in. That's the sort of thing you can do.
And is that the sort of amount of time? Like, okay, you've got a 60 kilowatt hour battery charging at, okay, so peaks, it's going to sort of go up and down depending on how full it is and whatnot. But 600 kilowatts, how fast would that fill it? Let's say like,
it's worth saying you can do a section of the battery at that sort of pace.
The middle
but,
bit.
If you want to do a complete fill, let's say you for the sake of argument, you're doing a test day or a track day or something of that order, and you've used the whole pack and you've come down. It's at the moment it's of the order of about 13 to 15 minutes.
Okay. And if you just did the sort of middle juicy bit, the fast bit, I don't know what's that from.
The juiciest bit.
Oh, so it's 0 to 80% or something is the fastest.
Effectively, the lower the state of charge of the pack, the faster you can charge it. So if you look at the charge rate, it sort of comes down like this as the state of charge goes up.
Yeah.
So if you want to do that really fast charge, you'd be right at the bottom of the pack, and you plug it in for a few seconds, and you'd absolutely smash the power in, and then you'd be off again. But it's not intended to be for a complete charge.
And then so if you did that, what's the sort of point of diminishing returns in terms of like, would it be 30 seconds and you get 25%, or what does that look like?
Yeah, it's of that order. I guess it's something that we looked at specifically because if you look at Formula E, for example, the racing that they're doing, there's this concept now of trying to do really fast, short and sharp pit stop charging just to enable a little bit more racing. And so, it's like a 30-second recharge to give you 10% of the battery. I need to the exact math to say that, but
something like that. Okay. And then, like, delivering that sort of power at a circuit, I can't remember. I heard someone on a podcast recently talking about installing chargers in their commercial building, and they were like, 150 kilowatt hour charger is the same as 5 of my building's usage in terms of like the actual amount running through it. Presumably in this sort of charger, do you just wheel it around in a backpack, or how are you going to have these in tracks and stuff like that?
I don't honestly know if we will, because it's I think that specific use case of the really, really high power charging will be if there's a motorsport application where and there's a desire to do a pit stop recharge, then you would do that really, really high power short burst recharge. To do that, the best way to do really high power short burst recharging is with batteries. So you would go from it's almost would be as simple as you would have another Speirling battery, a DC-DC converter between the two, and that's all you'd need.
Oh, okay.
And you've done 10% out of one of your batteries straight into the battery that's in the car, and both batteries are more than capable of. So the discharge rate of the first battery would easily do that sort of 600. So,
okay.
So you don't need masses and masses of equipment.
Just need a battery.
What becomes very difficult is at the point that you want to do, let's say, 600 kilowatt charging, and you want to do it for 24 hours, because then you've already very much depleted the battery that was in your garage that you're using to charge
50 battery packs or whatever.
Yeah, exactly. That side of it still needs improvement. But I think the thing that's important to say is you're absolutely right. Grid capacity is a tricky topic within electric motorsport, and no one wants to see a diesel generator charging an electric car. The best way, or one of the best ways to try and ease the amount of power that you need through the grid, is by having a really efficient small electric car, rather than having something that's 2 tons and is chomping through
Yeah.
absolute megawatts worth of power every time you hit the throttle. The smaller you can make it, the more efficient you can make it, the more feasible it becomes to just plug into the wall. And in the Silverstone pits and in the Donington pits, we've seen it too. It's relatively easy to get sort of 40, 50 kilowatts straight out of the wall plug.
Okay.
And that's obviously a slower charge, but if you're doing a more normal use case where I'm going out and I'm doing a load of laps and then I'm knackered and I'm having a cup of tea, it's easy to recharge the pack just using the wall.
Yeah. So yeah, your 50 kilowatt is going to be an hour and a bit, hour and a half or something.
Not even. And then so I mean, it's a 60 kilowatt hour pack. Generally it's slightly windowed, so a 50 kilowatt charge, you probably just over an hour.
Yeah. And then do you guys take 2 packs or multiple packs when you're testing?
No, we haven't needed to yet.
Okay. And you just work it out. And how long can you do on a charge?
So yeah, that is the question that has no easy answer. It depends how fast you want to go. If you want to go really, really fast, because of the way that sort of electric vehicles are, generally to go as fast as you possibly can, you have your powertrains reaching its temperature limit, your battery is absolutely on its knees of its temperature limit, and you push everything to the nth degree, and you'll get effectively like a single qualifying lap. Where if you're not only getting 1 lap, then you should be pushing it harder, sort of thing. Okay. So, that's sort of the absolute top of performance, and then as you come down, you get hugely more runtime as you start to allow yourself to come back to more normal run times, or lap times. Sorry. So GT3 pace around Silverstone is about 1:57 to 2 minutes a lap, something of that order. Yeah. We could do quite a few laps at that sort of pace, and even that is sort of quite fast for quite a lot of people.
Yeah.
So yeah,
and it's
decent run times.
And presumably it's fast in, like we were saying, it's fast in the weird places.
Yeah.
It's fast where the other cars are not fast.
Yes, and I know, and it's really efficient in its way of delivering really good lap time, because actually it's really energy consuming to do 220 miles an hour down the straight. If you can deliver a load of lap time by going really, really quick through the slow bits of the core of the lap, then that's a very efficient way of delivering a good lap time.
And does that also mean lower speed in terms of things like regen? How tricky is it to pull the power back out? I know it's not going to be a 1-to-1, but is it easier under? How does that work? Is it like, presumably a little bit of braking is easier to pull some regen out of, hard braking less so?
Yeah, so the proportion of the energy that you can recover is much greater when you're doing sort of gentle braking. So if you consider your normal electric car on the road, you can lift off the throttle and it's all regen, because it's just the brakes aren't even being used. It's just sapping as much as it can back out through the motor inverter into the battery. At the point that in your normal road car, if you're driving down the motorway and you stamp on the brake, a huge proportion of the energy then is just going straight into the brake discs, and that's why they're there, because you just can't shove all of that energy back into the motor inverter, and usually the hardest bit is into the battery. So the faster you go, the more difficult it becomes to regen a large proportion of the energy. And sort of, as I said a little while ago, you start to get to the point when you're driving really fast that the power that the brakes are delivering to or rejecting turns into sort of megawatts.
Okay.
And then that becomes, so you can grab some of that, and the slower that you go, the more of it you can get, and therefore the longer you can go. So it's a virtuous circle. As you start to go slower, you can get much longer run times. Yeah.
So the worse the driver you are, you get more unless you choose to drive, to brake less.
Yeah.
Has that been a point that you've been sort of developing and seeing changeover in the amount you can regen? And do you think that will change a lot over time or not? Or it's just really hard?
So we're making a really good step in the near future with what is effectively our third generation battery, and that's got even better thermal management, and that allows us to pump a higher level of power into the battery under regen braking. So from our side, we are seeing it improve, and it should only get better. What's really critical are things like the impedance of the cells, so their willingness to accept current flowing back into them, and that's also really affected by temperature. So if they're really, really cold, then it's very, very difficult to pump the power back into them that you would get from regen braking. But if you're able to keep them in this nice warm window where they're not too hot and they're not too cold, they're much more willing to accept loads of power. So a big part of the interesting engineering challenge is keeping the cells at the right temperature.
And what is that operating window of like optimum?
So generally speaking, for this sort of application, you want to be sort of 40 to 60 degrees is a nice window. Most of the cell manufacturers will tell you stay well clear of anything above sort of 70, 75, for fear of everything getting way too hot and damaging the cell. And if they're as you get colder and colder, as I say, the impedance of the cells increases fairly drastically. So you then have a lot less freedom to pump power back in.
And do you do a warm up lap, or do you just have you got heating sort of stuff in the car that it can warm itself up?
So at the moment we have a pit conditioner that's helping us with a lot of this. The sort of a concept of a warm up lap is not really necessary for the battery as such. But it's an interesting thing. I don't think we're fully decided as to what's the best thing to do in the future.
Yeah, interesting. Well, it sounds like an absolute riot. Sounds like possibly, like handling wise, with that type of downforce and stuff, and it's a pretty small car with a lot of power and rear wheel drive. Is it quite spiky, or is it?
So without downforce on, yes. But there's one final thing that's really interesting about having vacuum downforce is that it's independent of yaw. So you can be going at full sideways and you've still got all the downforce, unlike a wing.
Right. Yes.
So it's much more recoverable than obviously if you've got massive wings on and then you get into a big slide, you've lost all the downforce and you're backwards towards the wall. Whereas with this, you've still got a chance because you've still got all the downforce. It's inherently it's fun. I mean, that's first and foremost. It's a small car. It's got loads of power. That is just a dream, isn't it?
Yeah. Have you got a model for this on like Assetto Corsa or something that you can send down the post?
There's stuff in the pipeline that I can't really talk about at the moment. But I guess when I was younger, the car that we were all getting really excited about was things like the Red Bull X car, was it X2014 in Gran Turismo?
Yeah.
And it was this hypothetical car that used fans, and everyone would go around and do laps of the Nürburgring in probably 3 or 4 minutes or something utterly ridiculous. And obviously what we've created is very much of a similar philosophy. It's a car that truly sort of reinvents what's possible, and has started from a proper clean sheet. But it's a real car, and we're going to make them. So as you might expect, there have been phone calls made to us from people that want to see it in games.
Yeah. Right. So so you've got this car as it is at the moment, track, weapon.
Yep.
You'd like to do some racing at some point. Would that be a one make series, or will you try and sort of fit it into GT or something? Obviously, it can be a lot faster, but
Yeah, so
maybe for the running times.
it doesn't naturally fit anything that exists at the moment, and you sort of wouldn't expect it to, because it's never going to have the range of a combustion car, but it's got a lot more
Yeah.
performance than most combustion cars. So it is a bit different. In the long term, I'd love to see something that's not just a single make series, that is other manufacturers taking forward this technology, using electric cars, because that's what everyone wants to develop at the moment. Using fan-based downforce to actually deliver downforce very efficiently and with these wonderfully different sort of attributes. We haven't even talked about following, by the way. This whole concept of worrying about aero wake just is completely gone at the point that you've got a vacuum downforce system. So yeah, another cool attribute. And the noise when you apply it to an electric car, although if it was a really loud combustion car, you might say, well, it's not that important. But for an electric car, the thing you hear first from our car by a mile is the fan screaming as it's sort of echoing up in the grandstands, and it's wonderful. So single make series would be great. The sort of the general trajectory that we're heading for at the moment is what is really looking now. We've got what's really difficult to achieve with electric cars is an electric road car that is also track capable. If you look at the majority of performance electric cars that are coming out, most of them are the best part of 2 tons. And that's in my mind it's just a complete no-go for track.
It's kind of pointless.
It's so heavy that I feel, rightly or wrongly, that there's a need to have a car in the future that is compatible with future urban requirements. You can drive into the centre of a city. You can still enjoy it in the normal way that you enjoy a car, but you can still take it to the track and enjoy it too. And actually, this concept of when you get rid of all the redundant space, you get rid of all these extra seats that you're carrying around, you've really got this opportunity to make a properly compact, properly enjoyable electric car that's great fun on the road because it's compact and it's light, and it's absolutely ballistic on the track for those few times that you want to take your brains out and just go mad. And so that's where this is really interesting, I think, is looking at the future of this car in road legal form, barely road legal, but enough to drive through the centre of London and also set a lap record around any track of your choosing.
Yeah, that would be quite cool to be able to, drive congestion charge free into London, charge up maybe at the place for a couple of hours, have some lunch. There are plans for a road car version-esque at some point. Will it maintain most of the characteristics of the track car? So would you aim for a vacuum downforce system on a road car? Does that work? Is that allowed?
Well,
I don't know why it wouldn't be allowed, but
so there's some interesting points of discussion there, I think, and I can't say that we've got all the answers yet, and so I'd be wrong to try and blurt out what we think at this point. But I guess in its simplest form, a fan system is phenomenal on the track, and most tracks, most sort of track day cars have track modes and they have road modes, and so there's most probably there's an opportunity for something that meets both the criteria of being amazing on the track and being really cool on the road. And maybe it'll still make loads of noise on the road with a fan system, but that's probably just showing off. But then why do people buy Akrapovic exhausts or whatever they are? Yeah.
Well, yeah, and you've got the GMA T50 that has a fan system.
Yes.
Not the same level of downforce, but it has a fan system.
Yeah, and it's because that's really interesting, because obviously Gordon Murray, we have so much respect for Gordon. He's made such amazing cars. And really, if you look at things like the Rocket that he made many years ago, really compact, ultra lightweight road car, and obviously being responsible for the Brabham Formula One car that had a fan on it in the first place. But interestingly, the system that they ran on the Formula One car was closer to a sort of sealed system, more close to what we've delivered than his current T50, which is not a sort of sealed car. It's like a fan assist boundary layer improver.
Oh, okay. And then with your and then the skirts, presumably those wear away. They degrade in somewhat level over time, depending on the surface you're on, and etc. etc.
So
How has that been?
it's something we're learning about at the moment still, but actually with the right materials and the right people working on it, you can deliver something that really doesn't wear at any significant rate. There are some really amazing materials that exist now that probably didn't exist when they tried to do it in the 70s. Um, so yeah, will you ever deliver a car that where the skirt lives for the lifetime of the car? I think probably that would be a very brave thing to say, but it's not like they sort of instantly disappear. So yeah, we're working on it.
Interesting. And then let's say you've got a road car, then has this insane track capability. One of the issues that you get conventionally with a high downforce is you generally have to run stiffer springs or a stiffer suspension setup, which does not work on the road, and then also ride height. But actually, how does that all fit in, especially with the skirts and stuff? Does your car actually run a bit higher than normal?
So that's where I mean we use fully active suspension, and that is the best answer to it. So I think that's a relatively simple answer. It's difficult to do, but it gives you freedom to have a car that adjusts its ride height and its stiffness to the level of downforce that you're running at.
Okay, fair enough. Yeah, track mode, lowered, stiffer.
Yep.
Turn the fan on, off you go. With the fan running sort of full chat or whatever it is consistently, presumably that means you actually have like quite a consistent fan noise.
Yeah, you're right, and it's on a circuit you get the Doppler effect, so you always get this sort of meow as it goes past. If you sat in a traffic jam and you ran a constant fan speed, then yeah, it would just sound like a constant high pitched jet noise.
But when you're driving, presumably it does.
It does at the moment, yeah, and that's something where there's some interesting opportunities for us to develop. Because you're right. It's there. I think probably the answer to that will be having some degree of varying fan speed with car speed, but we haven't decided quite what the right solution is yet. From a lap time perspective, you just want all of the downforce all of the time. So from a driver's perspective, you've got a hum but because one of the things that's interesting about doing a carbon monocoque single seater with electric powertrain is the electric powertrain is right behind you, and the monocoque itself acts a bit like a drum. So a lot of what you're hearing is this sort of electric motor noise, and it's actually from a driver's perspective, electric cars, when done properly, sound fantastic. I think it's just that the noise doesn't carry, and so it's difficult for a spectator.
Yeah, you've got all the crazy motor noises.
Yeah.
And then with that consistent downforce, and I know it doesn't have necessarily any more drag, but presumably there is some sort of additional slowing the more downforce you run, or is that doesn't really come into it? So like on a straight.
So and this is the thing that sort of is an added benefit of the system a little bit. So with tyres, you get rolling resistance. The more load you put on the tyre, the more rolling resistance you get. So if you add to the downforce, the car wants to slow itself down because of the tyre drag. Having a DRS system that lifts off some of the downforce at the point that you don't need it helps with that. But you're absolutely right. If you add downforce, the car does get slowed by tyre drag. There's a little bit of skirt drag, but it's not that significant in the scheme of things. But one of the things when you compare that to a conventionally aerodynamic car, obviously because the wing load, the wing downforce goes up with the square of speed. At the point you're doing 200, 220, whatever it is, the load down on the tyres is absolutely massive. So the rolling resistance that you get at those really high speeds is way more than you'd actually want. Having the freedom to do this flat line downforce gives you the opportunity to tune how much rolling resistance you're dealing with at any one point.
And you can run a bit less stiffness because you haven't got these crazy high loads at the end of the straights.
Exactly right. Yeah, you can design a car around this particular set point.
That's quite interesting. And then, okay, so presumably, and like I haven't quite worked out whether you do it yet, if you, in the optimum situation, you might ramp down the fans on the straight, and then ramp them up as you're about to go into a corner. You could do. So you could have this really, really weird situation where you're driving, and as you put your foot down, the fans are doing the opposite of what a combustion engine would do in terms of they're revving down as you're going faster, and then just as you're slowing down, they'll rev up, which must be super trippy, so weird.
Yeah, I think you're absolutely right. That could easily be the situation, and wouldn't it be cool to be sort of dealing with something so different in a race environment? It's so different to anything else in that sense.
That thing of it, because you could have this stuff all controllable by your hands or set up or GPS or whatever, and you're like, I'm about to go into a bit where I need all of the downforce, and you're like, whoop, off you go, and then
we had this cool situation with Max the other day at Silverstone where I think he was on an outlap, and a sort of a GT3 car came herring up behind him, and he was sort of still warming the car up and doing a little bit of brake warming, I think. And the car comes around the outside, and he just goes switch, turn the downforce on, and you get exactly that noise. He just goes, and then he basically just disappears. And it's really cool in that sense. Loads of interesting opportunities to do different stuff. The actual driving experience with an electric car is really cool as well. It's very, very pure. I am a lover of manual gearboxes, heel and toe. I think that's a really interesting and engaging experience. With an electric car, you don't get that at all. You've just got throttle, brake, and steering wheel. But there is quite a lot to be said for if you're not there's a lot less to deal with, and so you can really perfect. I want to get exactly to that apex. I want to hit the braking point at exactly that point. There's an opportunity to be a greater perfectionist because you're doing fewer things. I think in the circuit environment, that's really, really cool.
I've totally found that, like with my Radical, I used to have an SR1, which is like the baby one, and that at the time you could have the sequential shifter, but they also introduced paddles, and I was like, well, to be honest, I love driving manual cars on the road, but the more I drive them on track, I'm like, okay, other than for the actual experience of driving that particular car on a track, like, give me paddles all day long, because I just want to focus on going fast, and gear changes can be a pain in the butt sometimes. Yes, there is a skill element, etc. But if you just want to go faster and faster and faster and faster, right foot, left foot, paddles, done. And in this element, right foot, left foot, done.
Yeah.
Do you get because you don't have gears, judging speed into corners and stuff must be much harder?
I think because the motor noise is so obvious in the cockpit, it's not that it is like having one really long gear, but you do get accustomed to the respective frequencies for the different corners. So you're not. It's not like you're sort of living in silence and you've sort of kind of got to guess completely from sight alone. But yeah, it's definitely different. I think one of the things you get with combustion engines is you go, well, this is a third gear corner. I know it's a third gear corner, so I get into third, and you don't have that.
Yeah, but then there is an element of you can learn the sort of RPMs. You go, this is a high pitched, this is a lower, etc. Okay, I get it. That sounds. And then some of the other, so with road cars, production and legalities and things like that, presumably you wouldn't look at making that many of these.
No, indeed.
And therefore you get to dodge a lot of, I don't know how you're allowed to make a Caterham, so presumably you fall under the same sort of category.
Yeah, I think we haven't fully concluded that side of things, but you're absolutely right. I mean, if we were to try and do full global homologation with this kind of car, I think a lot of what makes it interesting and different would end up being difficult to get through. Things like I don't think our fins are particularly sort of pedestrian minded on the back of the cockpit, and other things would be the same. So yeah, and as much as I'd love to think that there'd be a huge market for ridiculous single-seater electric track cars, I think it would be better to have the opportunity to make them really, really amazing and deliver them in more modest quantities.
Yeah. So if I came to you now and I wanted to buy one of the track cars, are you making? If you start, when do you think you'll start making, or have you already started making finished production customer level cars?
I'm going to have to say we'll be announcing stuff in the not too distant future. I think we're on a voyage of discovery and learning amazing things about these crazy technologies at the moment. And a lot of what we produce is now getting to the point where it looks really, really good. But equally, there's a big difference between making a car and making a batch of cars that you're happy will be really reliable and will make customers smile every single time. So, yeah, I think it's definitely on a roadmap, but I'm not going to give you a fixed timescale at this point. But hopefully, we'll be in a position where we'll be able to announce sort of what we're going to be up to in the not too distant future.
And what price bracket? Where are we looking at?
It'll be really good value, I hope, compared to all of these many multi-million pound electric and combustion hypercars that are coming out. But it's still going to, at the end of the day, it's still it's a hell of a lot of car, and deliberately so. So I've avoided the question.
What's the number? Vaguely.
I'm not going to,
between 500 and 1.5, maybe.
Yeah, I mean,
yeah. Or you don't know. You haven't read that.
The north end of that probably would be fantastic. But the reality is that we're still the bill of materials for this car is evolving continuously as we develop it. So it's difficult to give you a real number at this point.
So it's in the sort of electric hypercar-ish, vaguely territory ish.
I hope it will represent. It'll look like a phenomenally good value proposition in comparison to a lot of the new ultra performance electric hypercars that are coming out.
Sure, and I think it's it's a tool for a different purpose than all the cars that are out there at the moment. Like, this is a absolute track weapon in the proper sense of it. Not even like pretty much every track special that comes out from a manufacturer at the moment, I'm like, yeah, but it's really heavy and it's really slow in comparison to an actual race car. Whereas this sounds like, one, the tech is just so different that the experience will be so different from anything you can buy. There's nothing that's going to deliver this experience. Might be quicker, slower, sound different, whatever, but this is literally like, it's just going to be completely different. You won't be able to get this experience in something else, which is, I think that's quite cool.
Thank you. Yeah, that's certainly our intention.
And I'm hoping pitching at some point, maybe possibly have a little go, but like that may not be possible.
At the point that Max starts to say it's easy to drive, then we'll start we'll start taking on.
Start considering that. Yeah. I can imagine at the moment it's not.
I think at the moment most of the things that he says to us when he gets out is, "It's so fast," which is great. I mean, it's what you want to hear, right? It's just jumped out of Indy.
Yeah.
So.
Yeah, it's funny. I haven't seen the cornering shot, but I did see the video clip of the GT3 car behind him, and then him just like putting his foot down, and it's just seriously gone.
Yeah, there's so much potential, and you've got to play to the strengths of electrification. I think it, it's never going to win an endurance race, but to produce a combustion car that could deliver that sort of horsepower in this sort of size package would be almost impossible. So it's exactly as you've just said. It's going to deliver a really unique experience, and for the right people, there is a tick box maybe that they didn't have before, but hopefully they will have after listening to this podcast, which is I want to drive a fan car like Niki Lauda.
Yeah.
and this car will deliver that, and it will deliver it with phenomenal instant torque, huge power in a tiny package at an acceptable race car weight that we're continually striving to improve.
Yeah. Well, it sounds pretty cool. I normally wrap these up with 5 questions. Are you ready?
Yeah, go for it.
Do you have a most memorable driving trip or journey?
Yeah, so I went back in the rallying days when I was doing endurance rallying with our chief engineer, Kevin Coker. We did the Exmoor Endurance Rally in a Peugeot 205, and it was really, I mean, going back to the whole thing about having to convince your mates to get in a car with you and not throw up in the passenger seat. So Kevin was kind enough to do this thing. It's absolutely grueling. It's a full weekend of basically trying to read gobbledygook instructions that partially on the road, partially on rally stages, and trying not to throw up at the same time. But Kevin was kind enough to do this with me, and I don't think I ever succeeded in getting a co-driver to do more than one with me. So it's always out. But Kevin did this one, and we did pretty well to start with. And then we came across a back marker, and I made a bullish move, overtook him off the road, and we crashed into a tree stump and completely bent the tie rods. And we spent the rest of this rally still trying to drive flat out. But it bent in such a way that it would sort of rotate and it would change the tracking on the car. So you'd be driving along and suddenly you need to do that and it was so sketchy and pretty terrifying. But I just remember getting to the end of the rally exhausted, and then us both just sleeping in the back of his car. So that was a UK based Exmoor rally, and it was absolutely mad. Unfortunately, I think endurance rallying doesn't really exist anymore. I don't think they quite got the numbers, but yeah, what a thing. It was good fun.
That sounds pretty sketchy. If you could only drive one car for the rest of your life, and you have a very cheap £500 vehicle on the side, so that this vehicle can be a sports car if you want, and you can have something cheap to do family duties or whatever, if that's your thing. Yeah. What would you go for?
So the obvious answer is to say the car that we haven't yet released, which would be the McMurtry Speirling road car, but I suspect that's not a particularly interesting answer, but I do think that would be just an amazing, everyday, just ludicrous car. But given that if it's got to be a car that exists at the moment, I would actually choose, I think, a mono. I think I'd have a BAC mono. Ooh. And I would have, I'd have some sort of estate, or either an estate or like I don't know what you can get for the money. That's the problem. If it's 500 quid, it needs to be electric. I'm done with filling up my car at petrol stations now. I'm so over that.
I don't think you can get an electric.
Well,
you might be able to. A very, very, very old Zoe or something, but I suspect possibly not.
Yeah.
But yeah, so you're done with filling up. I feel that. I have an electric car as my sort of town run around short journeys, and whenever I get in one of the combustion cars, I'm like, I've got to go fill it up.
Yeah,
that's rubbish.
So, my cars at the moment they're not the most exciting, but I've got a Model 3, I've got an electric Volkswagen, so the 2 electric cars which we use all the time. And then just a few months ago, I got my absolute dream. It took me 3 years to find this. I've got completely mint, really low mileage Peugeot 106 Rally, which was the dream car when I was younger, but just couldn't afford and couldn't get insured on.
Yeah.
I've got one of those. So I still use petrol for that, but it's a weekend motor with it.
Nice.
Yeah.
Nice. There was a photographer, I think he was based in Belgium, that had a 106 Rally, and he always used to turn up to stuff, and I always thought it was cool. Yeah. Okay. Interesting. How's your experience of owning a few electric cars day to day, one Tesla, one not, been?
Yeah, mega. I mean, it becomes very clear, I think, when you make the switch that it's just the right solution. Um, occasionally you do get the whole range anxiety thing, and that's fine, because in my mind it gets cancelled out by having um, a fully charged car every morning sat there on the driveway. So I sort of yeah, I love the convenience. I'm so used to instant torque, and so sort of happy with the. I commute quite a lot of miles every day, and it just doesn't feel right to be just hoofing a load of CO2 in the atmosphere for the sake of trawling up and down a motorway. So yeah, it's just the right solution for me.
Yeah. I was very pleasantly surprised by having a small electric car. I really want. We keep seeing pretty much the opposite of what I want in electric cars coming out, and I think it's probably part of the process. But I want, like, let's say, like your car, but in a more practical kind of family type situation. I want the drive to be efficiency, and sort of needs to be small and efficient. And we keep seeing massive, like at the moment, what have we got? Like that the Hummer that came out in the States, and they've sold 50,000 of them, and it's like 5 tons or something like that.
Yeah.
That to me is the absolute opposite of the way this should be going.
Yeah, and I completely agree. And I think it's really tricky, because obviously the market seems to be demanding a huge amount of SUVs at the moment, and so the natural thing for manufacturers has been to produce an electric variant of an SUV, but naturally electric and SUV don't really go that well together, because you end up with just this mammoth machine that isn't really that environmentally friendly, because it's got a massive battery and it's not that efficient. But where electrification just makes so much sense is as you start to downsize, and you can get this virtuous circle of you make the car small, so it's got low drag, so you can have a small battery, you still get mega range, and the brakes are smaller, and the tires are smaller, and everything's just better. And
charge it quickly,
yeah,
etc., etc.
Exactly. Yeah, your home charger will still charge it in a few hours, or whatever it is. Whereas previously in the SUV generation, in combustion times, you just had like an extra 10 litres in your fuel tank, and no one really noticed. But when that equates to needing a 600, 700, 800 kilo battery instead, I think it all starts to go really wrong.
Yeah, and then you're charging, because I've noticed, so my car has a 46 kilowatt battery, something like that, and I can charge it overnight at home, just on a 3-pin, or in 6 hours or something on the wall thing, and that just works. And yeah, I would like a car with a bit more range. I can do, I think, like 160 miles of motorway, something like that. If I could do 250, that would cover like all of my journeys pretty much, and then a long one, you charge it a bit. But if you can just make the car more efficient, I know that's an easy thing to say, but like, make it more efficient, make the systems more efficient. If you could start to get, I think I don't know what I get. I probably get 3.8, what is it, miles per kilowatt hour on a motorway, something like that. And there was that Mercedes that came out recently, the concept that was doing about 8. I think that's gone to an extreme level. You're probably not going to see that translate into a road car that soon, because I think it was really lightweight and super slippery and not necessarily crazy practical. But if we can get to those numbers, or even close to that, like double where we're at now, if you get double the range, you're like, oh, I've got so much, give me a smaller battery pack.
Yes. Yeah, the Mercedes was done by a few friends of mine, and that was magic to see that. It's really nice to see a big manufacturer doing what is, I would argue, a relatively brave thing, which is to make a car that isn't just the same. It's not the same SUV format. It's not necessarily the prettiest thing ever, because it's really swooping rather than being sort of hunkered down and aggressive, as people sort of become accustomed to. But it's phenomenal in terms of its efficiency. Yeah, really, really exciting car, that.
Yeah. Right. What do you think is the most undervalued car at the moment? What should
I
be worth
think
more?
being an EV driver now, I think anything with a manual gearbox, petrol, and a relatively small engine in the future is going to be amazing, because petrol is going to get super, super expensive, as it already is. So, I mean, to be honest, anything with a manual and a petrol, I think will be amazing, because just the transition from getting out of a Tesla or Volkswagen into a Peugeot 106 with a manual box, it's become completely night and day. It's an experience that sort of I absolutely love, and I sort of didn't really expect to want a combustion car, but I absolutely love this one. So I think anything that gives you that sort of pure experience, ideally one that is pre all the safety aids where they did traction control and auto braking and all that other stuff that makes the experience less pure. So basically anything that's old and petrol, and probably V8, V10, V12 would be phenomenal, but whether we'll be able to afford the fuel sensibly in the future, I don't know.
Yeah, and then also, I think we'll be able to get fuel for a long time, but at some point in time, it's going to get really expensive, and you'll probably order it in barrels and do like a round trip from home or something. But yeah, your point about going from an EV to a combustion car is really interesting. I think it's very similar to, I always used to have, so I have some pretty fast cars at home and used to driving nice stuff around. But I'd go on holiday, and obviously what you do when you go on holiday is you rent the cheapest thing you can. And it's normally got a 1 litre in it, and it's pretty slow and a bit ratty sometimes. But then I come back home and I had a massive reset and rediscover how great, or the experience of driving these faster stuff. Yeah. And the EV one is sort of similar. It's not quite the same because they're quite talky, but yeah, that dead silence experience, whatever. And then you get in something with an engine, and you're like, ooh.
Yeah, exactly.
Ooh, this is interesting.
And suddenly your driving gets really bad again, which is EVs are very soothing, and they make you drive like a sensible human being. And as soon as you've got something that's sort of screaming at 6,000-7,000 RPM, you want to be there all the time, don't you?
Yeah. Right, most interesting car to you at the moment? Googling, what are you looking at?
So obviously that Mercedes you mentioned is really interesting, but I would probably go with, I really want this to succeed. It's been taking ages, but the car that's quite inspirational and cool is the Valkyrie. I think that's really nice. It's a proper shrink fit. Like it's got an amazing engine. It's a lovely. It's going to seem wonderful in the future. I think, and I think it's a really challenging project. It clearly is, because it's years late now. But I just want to see that one come through. It's what an awesome concept. It's sort of it's a similar essence to what we're trying to achieve, but in petrol form. We're trying to achieve something that's similarly radical, really shrunk fit, absolutely minimalist, as light as it possibly can be, real focus on aerodynamics, and we sort of delivered that in electric form, and the Valkyrie is arguably one of the best examples of that in combustion form, I think, that's coming out.
Yeah, I heard it at Goodwood last year. I know it didn't run too well or that often, but when it was running, wow. and just a thing to look at and appreciate. Like, this is, as a road car, and I presume on track actually is probably where it will really come into its own, the track car version. But this is just mad. This is cool.
Yeah, definitely.
But will it be too much for the road? Yes and no.
It absolutely will be. I mean, almost anything can be too much for the road with the right driver, can't it? But which sort of pushes you in the direction of, well, should you be looking to get the pro version, the sort of the track only one? But I think, realistically, you want the road legal one, won't you?
Or you're in that category where you're like, both, along with my lineup of crazy track Formula One cars and whatever. I'll have a bit of each. Why not? And then I'll take this to the pub every now and then.
Yeah,
and that's enjoy the craziness. Isn't it? Yeah, exactly. Yeah. Don't take a passenger. Got one shopping bag sorted. Yeah. Final question: 5-car garage, unlimited value.
Yep. So I'm actually the 5-car garage is going to include the 106 Rally that I'm really pleased to actually have. I've got to have an electric road car, and I would currently choose, if I could, I'm a big fan of estates rather than SUVs, so I would go for the Taycan Sport Turismo. I think they do that
Yeah.
GTS one that looks great in
Yeah.
I would have. So I'm a massive rallying fan, and as a result of Goodwood last year, I finally got to spend a bit of quality time with Sebastian Loeb because
Oh, cool.
he strolled over to the Speirling and just went like, "Oh my God, what is that?" which is phenomenal. So I sort of he was always my idol when I was younger, and I'd sort of be the guy that was like looking over the top of the crowd to try and catch a glimpse of him. And then finally got to meet him properly last year. So
That's cool.
I would have his 2008 Citroen C4 WRC car, and I would definitely compete in that. I would enjoy that a lot.
Nice.
I would have. I think I would probably have the 2016 Mercedes Formula One because I've worked so hard on it, and obviously it won championships, which is great. But I wouldn't, knowing how hard it is to run them and how insane they are as cars and how much could potentially go wrong with it, I would probably buy it and keep it, and then I would have a McMurtry Speirling for actually going really fast on the track and enjoying. So yeah, I think that's where I would be.
Did you have any toes dipped in the AMG One project at all?
It was happening. I was reasonably aware of it because it was happening while I was there, but I didn't contribute to it.
Yeah. That's another one that you're like, where is it? It's
difficult though, isn't it?
Tough.
So I mean, that's why when you said to me when are you going to deliver this car, because arguably that's another example of where you take something that you start with a track thing and you try and make it a road thing, and the outcome is often much cooler. I mean, the Project One is undoubtedly going to be a really cool thing when it finally comes to market, similar to Valkyrie. But it is tough, and it's not to be underestimated how much there is to do to get to that. And we followed the same journey. We've gone, let's make an outrageous, amazing track car, and then work out how the heck we get that on the road.
Yeah. I guess you won't have some of the issues that they have, in the sense of, it sounds like with both cars, the powertrain has been a real issue, getting it to just idle and like bumble around.
Yeah.
Because funnily enough, they're not designed to that. Whereas an electric motor, you just drive it slower.
Yeah, indeed. Yeah. I mean, in normal, sort of the normal speed that you would have the engine sat at on the dyno, which was sort of a relatively low damage, low consumption position, was 9,000 RPM. So it would idle lower than that, but that was the sort of the sweet spot where you had the least resonance in the gear train and that sort of thing. So to try and get it to sit at, I think the lowest they ever did was maybe 3.5 or 4.5, something like that. So yeah, I can imagine that was a mammoth task in itself.
If it wasn't the companies making the car that are making the car, I'm sure they could have pumped it out like years ago. If, let's just say, you were a small independent manufacturer based in America or something, and you're like, we've made the car, there it is.
Yeah.
Doesn't have to pass all these tests, these emissions tests, X, Y, Z, endurance testing. It's like, it's a track car. There's some plates for the road. Off you go. We'll see you in about an hour when it breaks down.
Yes. Yeah. But I think, the beauty of it is, hats off to these companies that have done something really brave and tried to produce.
It's cool.
Like they're mega companies. I mean, Daimler, Mercedes is sort of hundreds of thousands of people, isn't it? And yet they've done something really brave, tried to produce a really out there car. And I think I'd love to see more of that. Because it's all too easy to produce yet another SUV, and that probably brings in the big money. But actually, it's great that Mercedes have done that.
And you see certain brands sort of producing new halo cars that aren't technologically particularly interesting. Ferrari are exceptionally good at making money and selling cars, but they've brought out a few cars recently for the sort of, we're going to make 300 of them and blah, blah, blah. And it's basically a slightly more complicated rebody of an existing powertrain in a different shape. And there's nothing like, they're not trying to do something completely out there crazy, add another 3,000 RPM to the engine, or, some crazy aero or something. So it is, I mean, there's probably a lesson there for these manufacturers that are trying to do it. But I think you do have to just put your hats off to them, like Aston Martin, and go, Valkyrie project, if it hopefully finishes, you'll go, yeah, but that was standout.
Yes, absolutely.
And it will be remembered.
And I really hope that the same will be felt about what we've done with this car in the future too. Although we're a much, much smaller outfit, it's taken a huge amount of bravery and at a financial and sort of personal cost to deliver a vehicle that is this different to everyone else. So I really hope that will be true, that in the future people will look back and be like, those guys really went out on a limb to deliver something different and crazy.
Yeah, I think that's really cool. And I think, for all the team and the backing, like, to go for it, I think is amazing. I love another another guy I interviewed was David Dicker of Rodin Cars. Yeah. And there's some similarities in, a massive passion and a big business going, but this is what I really want to make. Let's make this, and let's make something pretty crazy and a bit mad. And yeah, absolutely hats off. And I hope, I'll see it some more, and I'm looking forward to what's going to come out in the future. Sweet. Brilliant. Well, thanks very much for coming on the podcast.
Thank you very much, Sam. It's great to be on the show.